So we will probably go a little bit into lunch. We want to make sure everybody has their time. So I will introduce the next speaker. This is Paul van Schayck from Maastricht. He's going to talk about designing an institutional research data management infrastructure for the life sciences.
Hello everyone, my name is Paul van Schayck, and I'm a PhD student and a data steward or data engineer within the Maastricht University Medical Center, the MUMC Plus, here in the Netherlands, and I'll talk something about the institutional repository and research data management services that we are providing. So the MUMC Plus consists of life science faculty and the academic hospital. And we're providing services, RDM services, for both of these groups. So for the academic hospital, the main challenges lie within keeping the research data that you collect, keep patient privacy, but also to extract information from the electronic health records, which can be a challenge. And also bridging the organization, so to because the MUMC Plus is a combination between the life science faculty and the academic hospital, it can sometimes be a challenge to link those two organizations. My talk will not be about the work that we do for the academic hospital. I'll focus my talk on the life science faculty. Within the life science faculty, there's many independent research groups. They do widely different things, starting from looking at cryo-EM, cryo-electron microscopy, to mass spec imaging, to next-gen sequencing, so many different data, very heterogeneous data. And this heterogeneous data also leads to very heterogeneous metadata. This is one of the challenges that we're dealing with. Finally, and I guess many of you are familiar with this, providing these services to these independent research groups means that you need to provide also the right incentives for researchers to actually use it. They're independent, and while we would like to convince them that having a bit more management on their research data is a good thing. So, a bit of background into life science. Life science depends more and more on collecting data in a multi-model way. So what I mean with that is that the volumes are increasing, but also the capability of researchers to use the machines to collect the data. And researchers are no longer keeping up with the amount of data that they collect. It's easier to collect the data to actually process and manage it. At the same time, life science is a small science, and with small I do not mean that there's few people working in it, but what I mean with that is that often the same person that is doing the experiment is also responsible for managing the data. Maybe a bit opposite to the previous speaker. In astronomy, you've got these large telescopes, and you actually got a multi-year plan how to maintain this, and you have specialized people doing this. At the same time, and you're all familiar with this, the call for open science and the call for open data, this also plays a big role within life science. So we've been working on setting up services within DataHub, and from the get-go we have been FAIR inspired, so adhering to the findable, accessible, interoperable, and reusable principles that have been published a few years ago. Coming out of these principles, an important part for us has been to structure our metadata and to enrich those using ontologies and semantics. What we do for users is to structure their data within projects and to have users have an oversight of the data they've collected. But be able to search for it, we built a faceted search interface using actually the semantics in the ontology enriched information from the metadata that we put into the metadata. And finally, because of the volumes that are increasing within life science, everything has been designed with and tested with high throughput in mind. So this is an oversight of the infrastructure that we and the services that we provide. This is the 2.0 version of it, which will actually go live somewhere next week. It's currently running in expectation. I will not go into all details of this slide because that would be a bit too much. So what I've done is in the next few slides I've picked out interesting bits in how we use iRODS, and I hope this can give you some inspiration of how to build your own services. But briefly, on the top left, you see, or basically on the left side, you see the ingestion side. Here on the top left, you see the data coming from the healthcare. The bottom left, which I focus on most, is the data coming from the life science. In the middle is are the core services with iRODS. In the middle of it, our data warehouse. On top of this, there's a number of governance and helping services that provide functionality to the core. And on the right side, there's a researcher again, which can interact with the system. And in between, there's different APIs that connect to the core. So one of the first thing I want to focus on is authentication. So what we provide is a federated authentication, and the way that we have done this is that the user logs into our web portal. And before logging into this web portal, he is provided with a SAML-based single sign-on service, which is provided here by SURF, the National Institute for IT Services for the Dutch institutes. And this SAML-based single sign-on will redirect you to your identity provider and will give us back your credentials. We use this then to talk to iRODS via iRODS-PHP over a proxy user. I'm not sure if everyone's familiar with that, but what that allows you to do within iRODS is to log in as a RODS admin user, as one user, and then actually present yourself as a different user. So we can talk to iRODS as one user using the credentials of the RODS admin user. So for the web portal, it looks like it's talking like the user we've just logged in without providing extra authentication. In the web portal, it's then possible to generate an iRODS temporary password. And using this, the user can log into the cloud browser and, for example, WebDAV, or even directly talk to iRODS. Basically, this is working very well for us as a way to provide federated authentication. One of the issues that we still do have is that we have no way to provision our users, not an automated way. So we still have to create these usernames ourselves, especially for external users. This would be nice to be able to automate this, so that users are also presented with the right forms before they can actually access the system. The next step is ingesting the data. And what we've done here is making use of a landing zone, which is still on an SMB SIP share, so a normal Windows network share. And the reason why we've done this is, one, because for the type of machines that users ingest data from is very diverse, and we did not want to have to bother with installing different clients. And the SMB SIS protocol is well tested, well known, it's performing on both Windows and Linux pretty well. So you've put it onto this landing zone here, but how do you then get it into iRODS? So the trick that we've done here is making use of iRODS mount collections. And these are basically collections that are visible to iRODS, but the files are not registered within iRODS. So the ICANN does not know about them, but you can still use, in most clients, you can still communicate with the SIF share. So then the next step is, the moment that we are happy with our data and we want to actually ingest it into iRODS, is that we use the collection rsync microservice to sync the data to a real collection. So this works well for us. disadvantage is that this method is not compatible with federated authentication because, of course, exposing your CIF shares over the internet, your SMB shares, is not wise or not even possible. The second issue is that we have is that the collection rsync microservice is not performing very well for us. It's not really an issue because users are seeing the CIF share as their way of entering data and not the step after ingesting. So it's less of an issue, but still would be nice to improve this. So once the data is actually in the is ingested, we ingest it into the project collection structure that we came up with, and we put a bit of thought into this structure. And at first we thought, well, let's use identifiable names, let's use acronyms for our projects, let's use defined titles for the collections, the project collections within the projects. But then we thought, well, this is probably not good. We want to keep this unidentified. So we started using these long unidentifiable names for both the project and the collections. And well, for users this is fine as long as they can find their information. And we also wanted users not to really think about their data in a hierarchical way anymore, but be able to use the faceted search interface to retrieve the information. And Mike Conway already spoke about this. Virtual collections would actually be a good way of being able to present your file structure in any way that you like. We've implemented something which is a bit close to this, and that we've placed within the cloud browser in this case. We make the title AVU that we've set on the collections visible. So here you see the project that you're in and the collection, and then here you can see the titles that have been added to this to project collection. Authorization, very simple actually, and I think this is really where iRODS shines. Being able to set up this kind of custom scheme and using the policy enforcement points and the rule engine to build your own authorization scheme. So what we've done is using the basic three echoes that you can set: own, read, write, and assign those to so own of a project, you're a manager. You can assign the contributor and the reader role. With write and read, you're the contributor or the reader. And you can either add users or groups to those. And groups are simply logistical units, departments within our organizations. And then as a contributor and also as a manager, you can create project collections within those projects. To adhere somewhat to the data lifecycle, what we've done is the moment project collection has the inherited echo, it's in the open phase and people can add data to it. And when the project collection is closed, we degrade all the echoes to read only, and then it's in the closed phase and the data is stored. Metadata, as I already mentioned, important to us. And the way that we try to model the metadata for all the different kind of users that we have. What we've done here is something what we call internally PISA. It's metadata on project, investigation, sample, and assay level. It's inspired by the ISA tools. I'm not sure if anyone's familiar with that, but they've created a good structure of how to annotate life science metadata. At the same time, we're compatible now with the HCLS dataset description for the life sciences. So within the web portal, we're using Islandora XML forms to create the forms. And these are linked up with an ontology lookup service from EBI, which we run locally, and also to the Crossref lookup. And then out from this comes a file, a metadata.xml file, which is validated, and then in our ETL process added to the collection. And at this point, persistent identifier using the Epic interface is added to the collection. As you can see, so our descriptive metadata is now in a file. It's not as AVUs in iRODS. This may sound a bit weird, mostly this has grown historically in our system, and we're not completely happy with it anymore. What we do like is that you've got this file, and when you export the data set, you still have this file. So this means that you can, so when the data is out of iRODS, you still have your metadata. And even when you ingest it again, you still have the metadata that you originally exported. So what we are now thinking about is to use AVUs for all the metadata, but then generate this metadata.xml on the fly. The next step that we do is index the metadata. So this file goes into MERT-Connect. MERT-Connect is the ETL tool that I talked about before. It comes from the healthcare domain, but it's basically a simple intermediate pipeline tool for us. And this then gets the message ready, our metadata ready for indexing in Solr. And in Solr, we index all metadata, the semantics that we get from the ontology lookup service, references from the crossref, and also the authorization on data. So that means that we keep all the authorization information available within iRODS, but also have this in the data warehouse so that we can index this again. So how do we use this then? So here, how do we use the semantics that we have? So here on the top left, you see the metadata form that we have, and then the organism. In this case, for the organism, we used an autocomplete form, and here we type Homo sapiens, but you could also type humans, for example, and then this is autocompleted to the ontology URI. And then after the indexing, what we can do is have a faceted search of this whole tree that we have. So we have this is basically the tree of life, and users can click on any of the nodes within this tree of life and then get not only the data sets that are on Homo sapiens, but also on vertebrates, for example. Deployment, what we're doing is using Docker for all the development. So it's actually possible to run the complete environment on our laptop. Unfortunately, what we can't do in Docker is run the Windows Active Directory, which we use for the SMB shares. So also storage is external. So while I can run it completely on a laptop, I still need a VPN connection for some of it. It's still being able to run the 16 containers and to redeploy. So what's the real benefit for us for Docker, with Docker is that the ability to rebuild your environment fresh all the time and to have a similar environment for all the developers. In exploitation production, this is slightly different. We use Ansible to actually deploy our Dockers, but also iRODS. This is also a bit of a historical reason, and I think right now you would be comfortable with also running iRODS within Docker in production. We have good results with that locally. I will not go into the reasons why we have to run MERT-Connect on Windows. You don't want to know. Also the web portal is then running externally in the production environment because it integrates with the web portal of the whole faculty. Of course, this leads to slightly different environments and the challenges that most of you are probably familiar with. What I will leave you with is something something that we see as one of the challenges that we have, is that within the data lifecycle, many of us in this room are working on the active data, so working on data that is actually being collected. And we're building highly specific RDM solutions. But at the same time, there's also lots of work being put into systems repositories that are more in the preserved phase. And for researchers, it's difficult to move between those two phases. And data now has to be transferred from one system to the other. And I think, and maybe others have opinions about this, is how to bridge this gap between the two systems that we're developing, both the active data systems that we're developing and the more repository long-term storage. And I'm interested to hear your thoughts about that. Okay. Thank you.
So we have a magic